Physics class. Good morning, everyone. My name is Muhammad Gias Uddin. My dear students, today we are going to discuss about another important topic. This topic is relation between phase velocity and group velocity. Relation between phase velocity and group velocity. Okay. Solution. We noted that phase velocity Bp equal omega by k. After cross multiplication, we can write omega equal Vp into k. So suppose this is our first equation. Also, group velocity Bg equal d omega divided by dk. So suppose this is our second equation. Now, from 1 and 2, Bg equal d omega divided by dk, and the value of omega is Bp into k. So we can write the value of omega, we can put in this equation Vp into k divided by dk. Okay. As we noted, ddx ub equal ddx ub, the product rule, u ddx b plus b ddx u. So this principle we can use in this equation. Okay. So d bp u ddx dk by dk plus k into d bp divided by dk. Okay. dk are cancelled. So bp plus k into d bp divided by dk. Also we note that k equal twice pi by lambda. Since k equal twice pi by lambda, this is called propagation constant. Okay. So we can write bp plus k, the value of k equal twice pi divided by lambda into dp dbp and d into 2 pi divided by lambda. Okay. Now bp plus twice pi by lambda into dbp and ddx 2 pi by lambda is, we can write 1 by minus 1 by lambda square into d lambda. So lambda and square will be cancelled to each other. Okay. And finally we can write bp plus this is 2 pi. Okay. 2 pi and 2 pi will cancel. So plus into minus bp and dbp divided by lambda into d lambda. So finally we can write bp minus dbp d lambda divided by lambda. So this is the relation between group velocity and phase velocity. So this is our required answer. For your better understanding, I am going to repeat it once again. We are going to establish the relation between phase velocity and group velocity. We know that by definition, phase velocity is Bp equal omega by k. Okay. And after cross multiplication, we can write omega equal Bp into k. This is our equation number 1. And also group velocity Bg equal d omega by dk. When the value of omega put in this equation, That means we can say that from 1 and 2, Vg equal d omega by dk. When the value of omega put in this equation, then we can write d into within bracket Bp into k, and this is ddx ub, and we know that ddx ub equal u ddx b plus b ddx u. Okay. So after solving this part, we can write Bp into dk by dk. So dk cancel to each other. K into dBp divided by dk. Okay. And also we know that k equal 2 pi by lambda. So we can put the value of k, we can put in this equation. So k equal 2 pi by lambda, and dBp d into derivative of 2 pi into lambda. Okay. After after calculation, after solving this part, we will get 2 pi by lambda into dp, 2 pi into 1 by lambda square. Okay, 1 by lambda square. So 2 pi and 2 pi cancel to each other, and lambda square and lambda will be cancelled to each other. So finally we can write bp dpb divided by lambda into d lambda. So finally we can write bp equal dbp d lambda divided by lambda. So this is the relation between phase velocity and group velocity. Thank you. Okay, sorry. This is equal to Bp plus 2 pi dBp into lambda divided by d lambda. So this is our final expression. So this is the relation between phase velocity and group velocity. Thank you.